Okay, so we're still, kind of looking at multi-step equations today, but we're opening the idea that not only are there going to be multiple steps, but there's now going to be the option that we can have variables on both sides of the equal sign. Which means when we're asking ourselves in step 1, are there parentheses? There might be multiple sets of parentheses because we will need to be considering both sides of the equal sign at the same time. So if we flip in our notes to that step 3, we wrote down in step 3 if there are, right? And then we left it blank. I really need to call the help desk. I don't know what's going on with this. It gets further and further off all morning. Okay, so if there are, and we're going to add to the list variables on both sides. Okay, and when I say variables on both sides, what do I mean both sides of what? Of the equal sign, right? So both sides of the equal sign. Okay, we are going to need to get them together. And you'll notice I'm very intentionally avoiding the word combine. Well, yes, there is math, and yes, we do get them together. It is not the same idea as combining like terms when we are in step 2. So in this situation, start with something very simple. Okay, we'll have something like 6y minus 8 equals 2y plus 7. Okay, so we'll just pretend for whatever reason, right? We've already taken care of step 1, we've already taken care of step 2. So step 3, are there like terms? Are there variables on both sides of the equal sign? Yes. So we have a variable happening here, and we have a variable happening here. We want to get those together on one side of the equal sign. There is not a correct side of the equal sign. I usually get students who have a preference from what they have already seen. They either already prefer to always keep the variable positive, or they prefer to always put the variable on the left because they really like their variable on the left. Okay, I tend to find that moving the smaller one is more of a preference. How many of you prefer to move the smaller variable? Yeah, that's just what I see from students learning before, so I just want to kind of stick to that same wording. So what's smaller, 6y or 2y? 2y. When we cross the equal sign, so I need to get this 2y from here to here. If you cross the equal sign, I'm crossing that line, you have to change the sign of the variable. So is this 2y currently positive or negative?
Positive.
Positive. So what is the opposite of a positive? A negative, right? That's our inverse operation. Now, just like we've been doing, whenever we write on one side, we also have to write on the other. Just be smart about where you write it. Don't write it underneath the 8, because that's not its like term. Write it underneath the 6y. Habits here are important. It will make a huge difference next week. Do not write this as just a -2. Make sure that variable is coming with it. You are moving that entire chunk. Okay, so 6y minus 2y becomes what?
4.
And then the rest we could solve from there. Literally all the other steps are the same, so we're not filling in any other notes today. I just want to look at a couple examples. So now flip to the end of where you left. I probably look like a weirdo to you guys. I do like weird hand motions and stuff. Flip to the end of where you left off yesterday. And we're just going to attach in a couple examples there. Because this is kind of like one big lesson. We just do it in 2 separate days. Maybe. It's doing its own thing. I don't know. Times 8 minus 4w equals 6w minus 4w plus 12 minus w. We are going to go down the exact same steps we were using yesterday. So do not let your brain think anything different. We just have to consider both sides of the equal sign now. Okay, so step 1 says, if there are parentheses, distribute. So do we see any parentheses happening up here? Yes, so we need to distribute. The parentheses are on the left-hand side, so for the moment, we're going to ignore all this. This doesn't matter right now. We're just focusing here. So what is 2 times 8?
16.
And what is 2 times a negative 4? Right, so minus 8w. Everything else comes straight down. Step 2, are there like terms on the same side of the equal sign? So we're going to look on one side over here. Are there any like terms?
No.
No. So let's look over here. Are there any like terms?
Yes.
Yes. So we need to combine them. So in my t-shirt company, I'm also going to have a saying shirt that says, if they're on the same side, use the same sign. If they're on the same side of the equal sign, we are combining like terms with the same sign. So what do we have to combine over here?
The 6w with 4w.
Okay, so 6w minus 4w is what?
2w.
2w, but are we done?
No.
Minus w. Do I have to write that 1 in front of the w? No. Doesn't matter. Everything else comes straight down. All the stuff in your way, Lindsay. Can you see okay? Okay. Then we'll move to step 3. Step 3 says if there are variables on opposite sides of the equal sign. So do we have variables on opposite sides of the equal sign? Yes. So we need to get those together. If they are on opposite sides of the equal sign, we need to get them together with the opposite sign. So we have a variable here, and we have a variable here. Which one's smaller? That would be tempting to say the 1, wouldn't it? But the 8 is negative, and negative is really small. Now, I'm going to go with the 1. Don't erase. I'm going to go with the 1 because that's what most of us said. Because I want to show you that that's okay. If you go, oh, I've heard, don't erase and start over. Just make sure your math is right. Right? So is this one positive or is this one negative?
Positive.
So how do we inverse or do the opposite of a positive one?
Subtracting.
The key here is that when you put this down, you just need to get this whole thing. Negative 8 minus 1 is what? Negative 9. So 16 minus 9w equals 12. Now, maybe Aaliyah and myself are both working on a problem. And Aaliyah decides to move the 1 and I decide to move the negative 8. Is our work going to look exactly the same? No, but does that mean we're wrong? No, so sometimes work can look very different, but still mathematically be correct. That's okay. Okay, what are we going to do next to solve this? Addition and subtraction, which is what?
That's positive, so subtract.
Right, this is positive, so I'll subtract. I think some of you are all just now cruising along, right? We're okay now? 12 minus 16 gives us what? Negative 4. What's a negative divided by a negative? A positive. So this is fine as a fraction. Okay, so do you see how we sort of have to consider both sides as we go? This also opens up the door for something weird to happen. So we gotta look at an example of the weirdness. Okay, just wanna make sure everybody's finishing up writing. You're okay. One half times 6a minus 12 equals 8a minus 9 minus 5a. Are there parentheses? Yeah, so what do we need to do? Distribute. I'm putting this one specifically up here because my students mentally make an error here. What is 1/2 times 6? 3. Half of 6 is 3. One-half times negative 12 is? Okay, so we have a minus 6. Now, lots of my students say, Mrs. McKinney, do I have to bring that whole line down if I recognize that there are like terms I can combine? No. Okay, I will give you that one. I totally understand that we can distribute here and see like terms here and not have to write an entire new line to do that. If you want to write an entire new line, go for it. I love it. If you don't, go for it. I love it. I don't care. Okay, so if we combine like terms over here, what can we combine? 8a minus 5a is?
3a.
Do we have variables on both sides of the equal sign? What's smaller, 3a or 3a?
3a.
3a, good pick. So what's the opposite of a positive 3a? What's 3a minus 3a?
0.
And what's 3a minus 3a?
0.
We all agree it's 0. Do not ever tell me that 3a minus 3a is 8. Do not make a variable magically appear because you don't like what's happening in a problem. These cancel out on both sides. So what do we have left over here? And what do we have left over here? There is no variable left to solve for. If the variable completely goes away, we then have a decision to make. Is this a true statement? Does negative 6 equal negative 9? No. If they do not equal each other, if it is a false statement, we say that this is no solution. There is no number that we can pick for A that is going to make this true. And hopefully that makes sense for us. If Charisma has so much money, and I have the same amount of money, but she spends $7 and I spend $2, can we ever end up with the same amount? No. If we started in the same place but did different things, we're going to end in a different place. Not the same place. Now, likewise, we can go through this exact same process. Pretend we did the other work beforehand, because who needs to make notes any longer at this point? I realize we are done. I see your faces. We have variables on both sides. What's smaller, negative 2y or negative 2y?
Negative 2y.
Negative 2y. And what is negative 2y plus 2y? 0. Is this true or false? True. Anybody know what we write if it's true?
All real.
Yes, I even love that word even more. I love this. All real solutions. All solutions. It is very tempting to say IMS, and we're actually going to talk about it. It is a true statement. This has infinite many solutions. And in fact, on state testing, there is a possibility that they will label this as infinite many solutions. It's not a wrong statement. It's not the best statement. Okay, what